So for the first one, since it's a right triangle, how do we find the third side? You got it. A squared plus B squared equals C squared. Pythagorean theorem. Which side is C? That's usually the easiest one to pick out. Across from the 90 degrees. So in this case, that'd be X. A and B can be either one of the other two sides. They just have to be the two legs. So we'll label them however we want to. So that means this is going to be 24 squared plus 10 squared equals X squared. So what does X come out to be there? 26 equals X. Very good. Any questions on that? You're confused, Andrew.
Yeah,
24 squared is 576. 10 squared is 100. That adds up to 676. The square root of that is 26. If you're going to enter it in your calculator, I would just do second square root 24 squared plus 10 squared. What's that? Yeah, you just got to put the square root in first. That way you don't have to come back and square root it later. You still look confused.
No, I'll figure it.
Okay. Down here. Okay. This triangle here is just an enlargement of this one. They're similar. So 8 became 12, so that's a ratio, 8 to 12. A 1.5 magnification factor. Yeah. And you can do that, then every side is multiplied by 1.5. And this is basically the same as doing that, you're just setting it up as a proportion instead of using a magnification. But we have here the 18, for example, is going to become at y, so y goes on bottom. Cross multiply and divide, 12 times 18 divided by 8. This should end up being what? 27. You got it. For x, we're going to do the same thing. We've got 8 to 12. 8 goes to 12. And now it's 12 goes to x. So 12 times 12 divided by 8 is going to give us 18. Does that make sense? Next, I want to review converting to degrees. If I give you 5 pi over 3 radians, or if I give you 3 pi over 4 radians, can you convert those to degrees? I'll give you a minute to convert those. So what we're going to do is this. This is going to be 5 pi over 3. We put the radians on top. And our conversion factor, radians are going to go on bottom, so they cancel, so degrees are on top. So 360 degrees equals 2 pi radians. The radians cancel, the pi's cancel. 5 times 360 is 1800 degrees. 3 times 2 is 6. 1800 divided by 6 is 300 degrees. Get it to work?
No, I was just asking because I tried to do it before, but I did radians first and then
Oh yeah, you gotta do the radians at the end and it'll automatically convert it to degrees. So then here, 3 pi over 4, putting the radians on top again. So here's going to be 2 pi radians on bottom, 360 degrees on top. And again, the radians cancel and the pi's cancel. 3 times 360 is 1080. 4 times 2 is 8. Is that 135 degrees that comes out to be? Let's convert to radians. Let's do 240 degrees. And let's do 15 degrees. I'll give you a minute to do those. So, 240 degrees over 1. Sounds about right, yep. So we're going to put 2 pi on top, radians, 360 degrees on bottom. Degrees cancel. I'm going to divide out 120 here to get 2 and 3. 2 times 2 pi is 4 pi. 1 times 3 is 3, so 4 pi radians. 15 degrees over 1. 360 degrees on bottom, so the degrees cancel out. 2 pi radians on top. Degrees cancel. Both of these divided by 15 gives me 1 and 24. I reduce the 24 and the 2 to give me 1 and 12. Pi over 12 radians. That's what you got. Convert to DMS. So if I give you 38.972 degrees and 12.315 degrees, convert to degrees, minutes, seconds. So you guys know the calculator function, so I'm just going to go through the actions here. I'm going to put 38.972 here in the calculator. And really all we needed to do is put the 0.972, because the first thing we're doing is take off the 38, which is our whole degrees. Then what do we do? Times 60. So that's 58 minutes. Subtract off the 58 minutes, and then times 60 again to go to seconds, 19.2 seconds. Or most of your calculators have the ability to go 38.972. Then you use your angle menu. It'll convert it for you. You can leave up to 1 decimal place in your seconds. It doesn't make a lot of sense because, like I said, I've never seen anything in this area that even measures to the nearest second. I mean, most places measure to the nearest like 5 minutes. So having a decimal second isn't terribly important. So we're at 12.315, so I'm just going to put the 0.315 in. Times 60. So 18.9 minutes, that's 18 minutes. Subtract the 18. Times 60 to make it seconds is 54 seconds. So 12, 18, 54. Going the other way. Convert to decimal degrees. So I have 27 degrees, 15 minutes, 42 seconds, or 53 degrees, 48 minutes, 18 seconds. Convert those over to decimal degrees. So we're going to go the opposite way. We start out with the 42 here. And we divide by 60 to get the 0.7. Then we're going to add the 15 minutes. So we're at 15.7. Oops. Now we're going to divide that by 60 to make it degrees. We'll add the 27 to that, which gives us 27.2617. Degrees. Over here, we're going to do the same thing. We're going to start out with the 18, and we'll divide by 60 to make it into minutes. add that to the 48 minutes, divide that by 60 to make it into degrees, so 0.805, and we'll add the 53, so it's 53.805 degrees. Any questions? Okay, I will